last class, we have studied about different types of ray formation and what are the images formed by those different types of ray. So today what I will do is, today we will solve the exercise, okay? So in page number 164, you can refer your book itself. Up to question number 10, I guess I have given you homework. Sorry, question number 9, I have given you homework. I'll start from question number 10. Okay? In question number 10, is to complete the ray diagram. Okay, incomplete ray diagram is given for both the lenses, so you have to complete the ray diagram. This is question number 10. There are two ray diagrams, A and B. A is a convex mirror and B is a concave mirror. Okay, so the diagram which is given in the book is like this. This is the diagram which is given in the book. One ray of light, incident ray of light, it touches the pole. Another incident ray of light strikes over in the mirror, and the imaginary ray of light, it touches the center of curvature. This is the incident ray. Now what you have to do is, you have to complete the ray diagram, and we know how to do that. You have to follow the rules which are meant for drawing the ray diagrams. Now what we know is, a ray of light which touches the pole will reflect back from the pole itself. This is what we have studied. Okay, to reflect back. This is angle I, this is your angle R. Now, this is an object, a dot is kept in front of the mirror, so you have to find the image of that dot. So to find the image of the dot, what we do is, we extend this line backward. Okay? This is for the ray number 1. Now for ray number 2, it strikes on the mirror, and then the reflected ray is not given. If it strikes on the mirror, what happens? It passes to the center of curvature. Now, the ray of light which passes to the center of curvature will reflect back from the same point that is the center of curvature. So, it will reflect back from the same point that is center of curvature. So, you can draw an arrow over there. The arrow shows the direction of the ray. And wherever these two meet, at this point is your image formed. So, this will be the completed diagram. In this case, similarly one object is kept, one ray of light falls on the pole directly, that is ray number 1, another it passes through the focus and it strikes the mirror. Okay, this is the first ray of light. Incident ray of light is given. Now you have to draw the reflected ray of light. Whichever light falls at the pole, it will reflect on the pole itself like this. Okay, this is the first one. Second one, the ray of light which passes through the focus will move parallel, will go parallel like this. Okay, so it will go parallel, and wherever these two rays of light meet, at that point will be the image formed. Okay, this will be the point where the image will be formed. This is for question number 10. Okay. Now question number 11 is similar to question number 10, so that will be your homework. And question number 12 is also a homework. 13, 14 and 15, you have to complete the ray diagrams. Like those are the ray diagrams which I have already drawn in the last class. Now all the question answers are partly the answers are given in the book itself, and those are simple questions, so those question answers has to be solved by you people itself. So now I will move on to the numericals. Okay, page number 166. We'll solve the numericals. So I'll start with question number 1. Question 1 is, the radius of curvature of a convex mirror is 40 cm. Find the focal length. So radius R is given as 40 cm to find the focal length. Now there were already 3 formulas which was given to you people. So using those one formula from those 2 formulas, we will solve this. Now what is the relation between focus and radius? Focus is half the radius. So your R is twice the focus. The radius is twice the focal length. Now from here, F is, this 2 will go in the denominator. So putting the value of R, what we get is, you can reduce this to 20 centimeter. Okay, this is a simple one. Now, question number 2 is similar to question number 1. So question number 2 is homework. Now question number 3, I'll do question number 3. Question number 3. Now this is quite a long question, so we'll use 2 different formulas for this. The question is, an object of height 2 cm is placed at a distance of 20 cm. Now, height of the object is given, we can denote it by O, capital O. It is 2 cm. It's placed at the distance 20 cm in front of a concave mirror. So, object distance mu is 20 cm of a focal length. So focal length of the mirror is 12 cm. These are the things which are given in the question. So next what you have to find is, you have to find the position, size and nature of the image. You have to find image distance, height of the image and nature of the image. So these are the 2 things you have to find. Now, from the given information, now we have to use a sign convention to see whether these things are positive or negative. For that, I'll draw a diagram, but this ray diagram is not necessary for your to solve the numericals. If you have an understanding of the sign convention, you can do it by yourself. You can imagine those signs, but if you don't have the knowledge of that, you can refer by drawing a diagram. So in this one, we are using a concave mirror. So concave mirror has got a focal length in front of the mirror. So anything which is in the left side of the mirror will be negative. So this will be negative. So the object is always kept over here in front of the mirror itself. So this object distance will also be negative. Now, what about the height? An object of height 2 cm is placed in front of the mirror. So when we place an object in front of a mirror, we don't invert the object, we keep it upright. So we assume that the object is like this, upright in front of the mirror. So anything above the principal axis will be positive, below will be negative. So this is our positive. So these are the values given in the question. Now next what I will do is I have to find the focal length. Now the mirror formula is 1 by F is equals to 1 by U plus 1 by V. In this question, F is given and U is given. You have to find V. So what we'll do is we'll keep V one side and take everything other side. So it becomes 1 by F. If you take this, the other side it becomes minus 1 by U is equals to 1 by V. Now what we can do is we can put the values. So what is the value of F? Minus 12. What is the value of U? It is minus 20 is equal to 1 by V. So from here 1 by V is equals to minus 1 by 12 minus 20 plus 1 by 20. Now LCM of 12 and 20. LCM of 12 and 20 will be your 60. Okay? LCM of 12 and 20 is 60. Now, over here, in the numerator, 12 into, how much is 60? 12 into 5 is 60. So 5 plus 20 into 3 is 60, so it will be 1 into 3. Okay, 12 into 5 is 60, so 1 into 5. So you have to write this. Now minus 9 plus 3 will be minus 2 divided by 16 divided by v. So if you reduce this, it will be 30. So 1 by v is equals to minus 1 by 30, or if you do the reciprocal, v is equals to minus 30 meter. Now from here what we can understand is we are getting minus 30. Minus means anything left side of the mirror. So our image will be formed left side of the mirror. So if this is your object, okay, if this is your object, now focal length is 12, so and this is 20, so it will be quite far from 12, somewhere here. Your object is up here. This is your object distance, which is 20. This distance is 12, and your image distance is minus 30. Minus means it is in left side of the mirror. If it comes positive, then it will be back side of the mirror. So minus 30 this side of the mirror. Somewhere here. The image will be somewhere here. Okay? Now, what I have to find next is we have got V, we have to find I. Now from the formula of magnification is equals to height of image divided by height of object. Okay, it is height of image divided by height of object. So height of image is I, object is 4. Another formula for magnification which I have already given you is minus V by U. So using this relation, we are going to find our height of image. So it is I by O is equal to minus V by U. So I is equal to minus V into O divided by U. So what is the value of our V? V is minus 30. Minus 30 into height of our object is 2 divided by U. Our image distance is minus 20. So this becomes minus into minus is plus. So 30 into 2 will be 60 divided by 20 minus 20. Okay, this can be reduced. It will be minus 3. So I is minus 3. Now what does this minus mean? Minus means anything above the principal axis will be plus, anything below the principal axis will be minus. So our image is below the principal axis. So it will be minus. The height of this will be minus 3. Height of this was minus 2. Okay. So from here we have found the size of the image has been increased. Okay. The image has been increased as compared to the object, and it is of height minus 3 centimeter. 3 centimeter, but minus because it is below the principal axis. So this is how you solve the numerical. Okay, I'll tell you again. V, object distance is minus 30. I is 3. And nature of the image, you have to tell from the minus sign itself. It is inverted. It is because it is in front of the mirror, it will be a real image. And it being back side of the mirror, it will be an virtual image. But this is a real image, and it is inverted and it is magnified compared to the object, because object was 2 centimeter long and image is 3 centimeter long. So one is magnified. Okay. This is for question number 3. Now I'll do another numerical, which is a different kind of a numerical compared to this one. So, okay. Now in question number 4, 5, 6, 7, 8 and 9. You have to solve it using the same formula. Okay, the formula is same, only the things which I have given might be of different values, but everything is kind of same. So you can do it, try it by yourself. If you have any problem, you can contact me. Now I'll solve question number 10. Question number 10. Question number 10 is, okay, a concave mirror forms a real image of an object placed in front of it at a distance 30 cm of size 3 times the size of the object. Find the focal length of the mirror. Now it is a concave mirror. The image is a virtual image of size twice that object, the concave mirror forms a real image of an object placed in front of it at a distance of 30 centimeter. So it is 30 centimeter. Now from the previous numerical, we know that object distance is always minus of size 3 times the size of the object. Now over here magnification is given, that is 3. Now one thing you have to remember, okay, if it is a real image, if the image is real, magnification will be negative. Okay, magnification, you have to put a minus in front of that. If it is a virtual image, the magnification will be positive. Every time with the numerical, if it is real, magnification will be minus. If it is virtual, magnification will be positive. Magnification doesn't have any unit because it is a ratio, and ratio doesn't have unit. Okay, and another information given in the question is the concave mirror forms a real image at distance placed in 30 cm of size 3 times the size of the object. We have to find the focal length. Now, from the formula of magnification, magnification is equals to minus v by u. Magnification is minus 3. Your v is not given. U object distance is minus 30. Okay, so from this given information, you can find v. So minus over here gets cancelled. So 3 into minus 30 is equals to v. V is equals to minus 90 centimeter. Now minus 90 centimeter, it means that minus means it is formed in front of the mirror. Image is formed in the front of the mirror. So from here we got v. Now we can use mirror formula to find the focal length and the focus. This is the mirror formula. So putting the values of v and u, you can find f. Where u is minus 30 plus v is minus 90. Now LCM of 30 and 90 will be 90. Over here it will be minus 3 minus 1. Okay. 30 into 3 is 90, so 1 into 3 is 3. 90 into 1 is 90, so 1 into 1. Minus 3 minus 1 will be minus 4 by 90. So 1 by f is equals to minus 4 by 90. Or f is equals to, we'll just do the reciprocal. So 90 by 4. If you divide this, you get around 22.5 centimeter. So this will be the focal length, that is 22.5 centimeter. And there will be a minus in front of that. It means that the focus also is in front of the mirror. Okay? This is for question number 10. This is what you have to find. The focal length of the mirror and